In this video, we are going to look at graphing sine and cosine functions with transformations. So before we actually get into the whole transformation piece, we're going to look at the generic y equals a times the sine of b times the quantity of theta, or you can think of it as x either way, minus c plus d. Where, keep in mind, as you hopefully learned earlier when you're doing each of the individual transformations, A is your amplitude, B is dealing with the horizontal shift, the horizontal stretch, C is dealing with your horizontal shift, and D is dealing with your vertical shift. So we're going to put all of this together now, and we're going to add in the one that we excluded before, and we are going to look at having this B multiplier in there, which is going to affect those x values or those theta values. Before we start with sine and cosine, it's important that you realize which graph starts where. The coordinate point 1, 0 is really that key leading point. So when I look at my 1, keep in mind the coordinate point, the first one here, the x value is the cosine value. So when I'm looking at 0 radians, my cosine is up at 1. So the cosine graph always starts at 1. Versus my sine, remember your sine is your y's, the sine starts at 0. So that's actually at the 0, 0 coordinate point for sine. Cosine always starts at that max, which is 1. So always keep that in mind. If you ever get confused, think about your unit circle and which point starts where. Because if you start with the wrong graph, everything's going to be thrown off. So to begin with, we are going to look at graphing the following problem. Y equals the sine of 1/2 theta. We're just going to do a quick little review before we get into all of the different transformations at once. All we're going to look at is having a single multiplier of theta. And I'm going to step back here for a second, and instead of doing 1/2 theta, let's start with 2 theta. The b value, the 2, controls your period. So for sine and cosine both, one complete cycle is 2 pi. And the period itself is 2 pi over b equals your period. So that's when your cycle should end. So normally when there isn't a multiplier, in this case that 2, that b value is 1. So one complete cycle is going to be 2 pi. However, in this case, my b value is 2. So I'm going to substitute 2 in place of this b. So I have 2 pi divided by 2 equals my period. So my period is going to start someplace. We're going to initially here start it at 0, and it's going to end at pi. So my entire graph for one cycle should fall within this region. Normally, it would fall within this region. So what we're doing is we're shrinking it. So that value of 2 is actually shrinking in what my actual graph is going to be. So I'm going to graph the parent function, which is y equals the sine of theta, and then we will do the horizontal stretch and shrink. So I've graphed my 5 key points, my 0, 0, because sine starts at 0, and then it ends at 0 at 2 pi. It's also at 0 wherever it starts and stops. Before we do any kind of transformation, this is always at that same value. So then I'm going to connect these values, and there's one cycle. Now we're going to continue these. We're not always just going to graph one cycle. When you look at my answer keys, I've always filled up my entire graph. You'll do the same thing, just keeping in mind that if I go past 2 pi, this is 5 pi over 2, which comes up, and then comes to 0, and then etc. So just be careful, just making sure. I like to draw my dots here first. That way I don't jump too far ahead of myself. Okay, and then I can keep going backwards as well. Dot, 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 etc. So there's one whole graph filled up. So here's my original parent function. So now what I'm going to do is I have to take that parent function and I have to change it according to the period. Before it went from 0 to 2 pi, that was the length of it. So this from here to here is the length of one period. But now instead of going out to 2 pi, now it's only the length of pi. So now if I start at 0, I have to end at pi. And you can kind of count and use your tick marks to help you kind of see where does it start and stop. So going again from what I had initially, here is one cycle. And I'm going to start just with one cycle. It's much easier to work with one and then continue after you finished one cycle. That's my opinion. So now that I have this one cycle, now I need to make my end point, which was out here, it now is cut in half. So I have a starting point still here. Now my ending point is halfway in between. I'm going to get rid of this blue dot. So then what happens in between? Everything else is halfway. So for sine, halfway between my starting and ending point is 0. Halfway between my starting point and that next 0 point is my max. So halfway, I'm going to have to go directly in the center here. And then halfway between my middle point and my ending point is -1. And we connect our dots. And that is going to be your graph for the sine of 2 theta. Now what I'm going to do is I'm going to pull these graphs off of here. I know I have points too. Got lots of messy stuff on here, but things just to keep yourself organized. This is one cycle. So now if I keep going, I can see that every time I hit a pi, I have this pi over 2, pi, 3 pi over 2, 2 pi, etc. Those are at 0. So this keeps going up. Everything is always halfway because it's those 5 key points. So there's my next 5 key points. Starting point, max, 0, min, 0. And then I can keep going. At least complete from 0 to 2 pi, or if it's even bigger, at least complete one cycle if possible. Okay, so that's dealing with the sine of 2 theta. Now we're going to do the one I was going to start with, and now we're going to do the sine of 1/2 theta. The period here is figured out through your b value. So 2 pi over b equals the period. b is 1/2. So 2 pi divided by 1/2 equals my period. Dividing, change that into multiplying by the reciprocal. Therefore, my period for this problem is 4 pi. So now it's going to stretch itself out. One complete cycle is going to be 4 pi. So again, I've started with my parent function, and I can connect these dots, but those are those 5 key points we're going to be performing my transformations to. So I'm going to look at, now my period is 4 pi. So now from start to finish has to be 4 pi in depth. So starting point, ending point is at 4 pi. Now my middle point is always a 0 for sine, as it was here. And then halfway in between are the other 2 points. So at pi, I have it up at 1, and at 3 pi, it's down at -1. Connect, and it's quite an extended graph. So in this case, oops, when my b value was a fraction, it actually stretched itself out. Now, we're not just going to be looking at one of these at a time. We will be looking at multiple ones. We're going to have all different types of transformations. We may have all 4 of them, for instance, at one time. The next one I'm going to do has 3 of them, just to take you one step further, and then we'll do one with 4. I'm going to do cosine this time, just so that you can see both of these work the same way. So we will look at graphing y equals 2 times the cosine of 2 theta, 2x, however you want to say it, plus 3. Now, if you notice, there is no parentheses around the plus 3, which means the 3 is actually affecting your y value. So the only thing that's affecting my x is the multiplier of 2. So a couple of things you may want to write out so you don't lose them. We have this 2 in the front. That's my a value, which is my amplitude. So my max is going to go up to 2. My min is going to go down to -2. And then I have the 2 theta here. I'll use a different color. So this part here, that's my b value. So 2 pi over 2 is going to be my period. So my period in this case is going to be pi. So from start to finish, one complete cycle is going to be pi. and then I have a shift up of positive 3. So this is my vertical shift up 3. So now you have to decide, okay, how do I want to graph this? What's going to make it the easiest for me? You get to choose what makes the most sense for you. My least preference or my least preferable values to deal with are my x values, because that gets ugly in terms of pi over 2, pi over 4, pi over 6. My vertical ones are usually pretty easy. I have a multiplier, and then I may be just adding or subtracting, moving things up and down. So that's part of what you have to kind of just think ahead about. This problem is going to go slightly, oh, it might actually fit. If it goes slightly off your graph, that's okay. You can always change your scales for these vertical scales at least. So to begin with, for cosine now, let's look at my cosine value. So going back to your unit circle, cosine is your x, so when it's 0 degrees, it's up at 1. So cosines always start up at 1. Part of the reason cosines are actually my favorite graphs. And then it also, 0 and 2 pi are the same, so it ends at 1. If you look at your graph halfway in between at pi, it's negative 1. And then in between there is pi over 2 at 0, and in between there is 3 pi over 2 at 0. So this is going to make a nice little graph. I'm going to go out one more cycle just so you can see what takes place. All curves, no V's. Sometimes it looks kind of V-ish, but those are curves. So that's 2 cycles. I'm going the positive direction. Again, once you get one of your cycles down, you can then continue that pattern and make more. So we will start with just looking at one cycle so we can see what takes place physically with this one piece. So I prefer, again, to deal with my y values first. Keep in mind we have this axis in here, which is called your principal axis, or it's one of the words. That principal axis deals with the vertical shift up and down. So that axis will change. My recommendation to start is start with your amplitude. Start with your max and min values. Before it was at 1. Since my multiplier is 2, I am now going to take my max values and pull them up to 2, and take my min values and pull them down to negative 2. And then these zeros stay put, which is one of the nice things of multipliers. And I have my next graph. So initially, I had my parent function in blue. Now with my amplitude A, I have the green. And I'm going to try to clean this up the best I can. Please bear with me, as sometimes it's kind of hard. Okay, so now there's my graph just dealing with my amplitude. So my multiplier is done. Now what I can take a look at is my shifting. This is shifting 3 units up. What happens when it shifts 3 units up is it takes the principal axis and the graph and shifts everything up 3 units. The easiest way, again in my opinion, to do this is take each of the individual points and add 3 to them. Specifically, 5 key points. Look at your 5 key features. So this was at 2, add 3, it's up at 5. Here was my other max, add 3. My min was at negative 2, add 3. These values were at 0, add 3. This value over on this side was 0, add 3. You have your principal axis through here. And now I'm going to cheat. And I'm just sliding it up. I'm going to clean this up. So now my principal axis has slid up 3 units, which means my max and min should still be each on opposite sides of that principal axis. And then I've also included my multiplier of 2. So I have 2 of the 3 different transformations done here. The last one is the new one that we're working on today, and that's my multiplier of 2, which we again said my period is pi. So start to finish has to be pi in depth. So it started at 0. I'm going to now have to end it at pi. So start still stays at 0. End is my max. That's at pi now. Therefore, halfway in between is my 0. So now I have to go halfway between. And then now everything else is halfway in between, which is part of the reason I also always include all 5 key dots. Then I don't have to question where it should be. And I connect. And I'll move this one out of the way. And now if I know I start and finish always at pi, I can put another cycle in, my next finish, so this goes to pi, so my next finish is at 2 pi. My min is halfway between there, and then I've got halfway between, rough estimate, right on that principal axis, which is why we draw it there. And again, nice round curves. And now I have 2 different cycles for my graph, y equals 2 times the cosine of 2 theta plus 3. The next graph I'm going to do is going to include all of the different shifts. And again, I'm going to give you my recommended way of doing it. That way you can kind of see what I do. And you can always switch it up if you want. If you see it easier a different way, that's fine. Our goal by doing this is so that we don't have to try to figure out what all of our values are using our calculator. These can get quite ugly, especially if we start adding and subtracting left and right in addition to the multiplier. So here's our next problem with the parent function already on here. With this, I have 3 different things that are taking place. I have an amplitude of 3. I have to deal with this mess in the middle, and then this 2 is going to be a shift up 2. Now the part in the middle I have to worry about because it's b times that quantity. So I actually have to factor out any multiplier that's attached to my x. So I have to factor out a 1/2. So I'm dividing it by a half, which means if I divide a half out of the pi over 4, if I'm pulling that out, it's like multiplying by the reciprocal, so it's pi over 2. So now I have a horizontal stretch of a half, and I'm going to have to shift this to the right pi over 2 units. That's the part that's the worst. So I'm going to do the other 2 parts first. I'm going to do the amplitude, and then I'm going to do the shift up. Go fairly quickly with that. That part is not too difficult in terms of having integer values. And then afterwards I'll then have to deal with the x part, which does get a little bit more complex. So I have an amplitude of 3, so I multiply everything by 3, which means my max was at 1. It's now at 3. My min was at -1. It's down to -3. My zeros stay the same. Okay, that's on there. Now I have to do my shift 2 units up. So every one of these points physically shifts 2 units up. When I do that, ooh, that was kind of ugly. I also will draw on my principal axis. And my principal axis goes through those starting points, which is part of the reason I think it makes it a little bit easier to keep track of. Now I get to deal with the inside piece, dealing with the period and then also the horizontal shift. So I know this 1/2 is my b value, and if you just can remember that 2 pi divided by b is always your period. So I'm dividing by 1/2, which is the same thing as multiplying by the reciprocal. So my period is going to be 4 pi. So from start to finish, it's going to be within 4 pi. The other part that I have is my shift pi over 2. I recommend doing your period first and then doing your shift. Because once you figure out your period, everything goes halfway in between. You're usually still dealing with some pretty nice values. Then you can just move each of those as you need to. So if I deal with my period here next, my 4 pi, then my starting point stays here. My ending point pushes all the way out to 4 pi. And then everything again is always halfway. So halfway between 0 and 4 pi is this 0 value, which is now at 2 pi. And then everything else is halfway in between. So my max now is halfway between, which is at pi, and my min is halfway between 2 pi and 4 pi, which is at 3 pi. So now connect to that. It's a nice spread out graph. And now that I got rid of the other one, now the very last thing I have to do is I have to do my shift. It says minus pi over 2, which means I have to add pi over 2. So everything has to shift pi over 2 units to the right. Downfall to this, with my period being 4 pi, it's going to fall off of my graph. So what you may want to do, again, is do another cycle going in the opposite direction. So again, keeping in mind everything goes accordingly. So one way to use this is at 0, here I'll use a different color. At 0 it was here, and then my next 0 was at 2 pi. So I'm going to kind of go in that same direction backwards. So therefore I'm going to have another 0 over here at 2 pi and another 0 over here at 4 pi. It follows a nice curve. My mins are going to be at -1. My maxes are going to be at 5. Halfway in between. So at -pi, I'm going to have a min. Up, I'm going to have a max at 3 pi and 5, and then down to my min. Sorry, that's not the best curve. But there's 2 complete cycles now. Again, the big reason I did this is because I have to shift it pi over 2 to the right. This shift is pi over 2. So the amount I'm going to have to add is all of these points are going to physically move that distance, which according to this graph is 3 spots. Now it might be pi over 8. So you have to be creative in looking at what these are. Okay, pi over 2 is 3 spots across. Pi over 4 is halfway between. Pi over 8 therefore is halfway between, so it's like 3/4 of a box. So think about how many boxes that is and move your points. It is to the right because it's the opposite and it says subtraction. So this point here moves pi over 2 over. This point here moves pi over 2 over, which again are 3 boxes. Everything moves by 3 boxes, which is why you have to be really, really precise. And then that point's going to be off, so I'm going to leave that one. I'm going to go backwards and do all my other points. So this point here moves 3 boxes, moves 3 boxes, 3 boxes, and 3 boxes. So I played the connect the dots, and it doesn't stop. It does keep going after this last point, so I'm just going to turn it upwards. As to which direction it goes will be decided. On the left end of this is going to keep going, so I'm just going to draw an arrow that way. It's going to keep going in that manner. And then lastly, get rid of all of the points, all of those extra points, almost. And this is what the graph looks of y equals 3 times the sine of 1/2 x minus pi over 4 plus 2. If you struggled with any of these examples, you may wish to re-watch any of the given examples or do some searches on YouTube for looking at graphing trig functions through transformations. So I would stay away from tangent right now just because of all of their vertical asymptotes, and when I start doing my phase shift, which is what's called the horizontal piece to it, is going to start to get a little bit more difficult. So I'd stay away from the tangent for now. We'll talk about that later.